Hello viewers, welcome to our TSOL Global YouTube channel and our tutorial series. So in this series, we'll mainly discuss how you can design and do measurement of different electrical and electronics circuits and devices. In our previous video, we discussed how you can measure current in a circuit using a current meter or an ammeter. So today we'll discuss how you can measure current in a circuit using another method, which is by using a voltmeter. So at the end of our previous video, we asked you how you can measure IDD current in this circuit where VDD is a DC supply and there are two resistors R1 and R2 are connected in parallel. So how you can measure the current IDD, which is the main current of this circuit. To measure IDD, first of all, you have to configure your multimeter as in current measurement mode or as an ammeter. So next you have to remove a part of where the wire is the main wire which is flowing like from VDD towards R1 and R2 resistors. Now you have to connect your multimeter probes in that wire like this, and it will give you the total current IDD in this circuit. Another way to do it by removing a part of wire from the ground is the main ground, and you have to connect your multimeter probes in that part, and it will also give you the IDD current. So your IDD current is basically the total of your I1 and I2 current. Now moving into the next part of the video. So here we will mainly discuss how you can measure the current IDD in the same circuit with another method, which is by using the voltmeter as an ammeter. At the end of our previous video, we discussed the general user, they basically buy very cheap multimeters which cost from £10 or $10 to £100 or $100. So in those multimeters, there can be different problems in the ammeter. One of them can be the ammeter is broken, or the ammeter is not even present in those multimeters, or the ammeter or the current measurement part, it doesn't cover the range of current you want to measure. So to solve that problem, we can use the voltmeter of the multimeter as an ammeter, or you can use the voltmeter to measure the current you want to measure. So to do that, first of all, here we connected a resistor Rm in series with the IDD current, and the Im current is flowing through the Rm resistor. So Im current is basically the same current as the IDD current. So because of this Im current flowing through the Rm resistors, we have a voltage drop Vm in this resistor. So here we selected 1 ohm as the resistor for the Rm. You can select other values here, but using 1 ohm will make the whole process easier. If you use other values, it will make the calculation more complex. Next, we connect the multimeter probes in parallel with Rm resistor. Now we already said the current meter or the ammeter in this multimeter is broken. So what we can do is, now we can configure the multimeter as voltmeter, and it will give you the voltage Vm, which is basically the current Im. How this Im current can be calculated from the Vm voltage, it can be explained from a very basic law, which is Ohm's law. We know from the Ohm's law that V is equal to I into R, or we can also write I is equal to V by R. So in this case, or in our this circuit, now we can replace these values and we can write Im is equal to Vm by Rm. Now here we have Rm is equal to 1 ohm. If we put that value, then we can write Im is equal to Vm by 1 ohm, or we can write I of m is equal to V of m. So it means whatever value you are getting in your voltmeter from this RM resistor, which is 1 ohm, is the same value of the current which is flowing through the circuit, which means your IM current is the IDD current, which will be equal to your VM voltage. So in this method, you can get the value of the current directly from your voltmeter. You don't need to use the ammeter in this case. So one specification you have to remember when you are selecting the RM resistor, which is the power of the resistor or the power specification of the resistor. The power specification of the resistor has to be more than the power of the circuit you are doing the measurement. So this is the end of our video. In the next part, we'll explain the theory behind the voltage and current calculations from our previous videos. And please consider subscribing our channel for more videos like this. Add likes and comments. Also give us suggestion what kinds of videos you want from us. Also follow us in LinkedIn, Twitter or X, and in the Facebook. Thank you for watching.